Hi, in this video we are going to talk about how to implement the Runge Kutta solution for differential equations. So let's get started. I'm going to include the IStream. I'm going to include, I'm not sure, we will need it, the math.h. And I'm going to include the fstream because we are going to create CSV files. So using namespace std, we will have a function we want to integrate. So double x, double y. We don't even have y. It's going to be just one parameter. So we will have a double dx is equal to 0.5. We will have a double x is equal to 0.5. We will have a double y is equal to 2.5. It's going to be the starting point. And if you are familiar with the Runge Kutta method, we will have it is the fourth order Runge Kutta, so K1, K2, K3, K4. Mathematicians usually refer to these parameters like this, so I'm going to do the same. And before starting it, we want to integrate the function double f with double x. For example, return x. In this case, it's the differential equation that dy divided by dx is equal to x. And if you are familiar with how to solve differential equation, this is exactly that. Epsilon, I mean y, x is equal to 0.5 times x times x, so x squared. And it's the function of the parabola. Yeah, so if we want to plot it, we should get a parabola like this, something like this, an exponential function, kind of an exponential function. So here we have an rstream data file. The data file that's open, for example, data.csv. Yeah, of course I will have to data file that close, and I'm going to return 0, and for int I is equal to, or let me call it int count equal to 0, count less than, for example, 150, count plus plus. And we just have to calculate these key parameters. The key one is equal to the f function. Oh, of course, sorry, I definitely need the double y, although double y it's going to be independent from y, but just for to be explicit, we have to define it. The k2 is equal to f x times x plus dx divided by 2, and epsilon plus k1 times dx divided by 2. K3 is equal to f on x plus dx divided by 2. It is the so-called Runge Kutta formula. You can look it up on Wikipedia, whatever. X plus epsilon, I mean y plus k2 times dx divided by 2, and the k4 is equal to the f with x plus dx, and y plus k3 times dx, and y is equal to y plus 1 divided by 6 times k1 plus 2 times k2 plus 2 times k3 plus k4 times dx. Okay, I forget to put a dot here. Okay, so that's all about the x. We have to increment x equal to x plus dx, and of course I have to see out x, y, and line, and of course I have to write it to the data file x, y with an end line. And what's the problem? It's dx. Yeah, we just have to run it. I mean, build a project. I think I have already built a project and run it. I think it's going to be correct. Yeah, it's look like correct. It's going to increment exponentially. So let me test it. We just have to import a file, upload a file. I have to select the file you want to upload, the CSV of course. We have to specify the x-axis, the y-axis, line as plot, and line a plot. And yeah, it's going to give us the exponential function we are after. But if, for example, we want to simulate the same function as earlier, for example, it was something like this. With x times epsilon. It's going to be the same, but much less. It's not going to... Okay, I'm going to import a file with data. The slope is going to be x and y, and I have to plot it. Yeah, it's going to be the same, but the slope is not going to be as emerging as before. So that's all about solving differential equations with the help of Runge Kutta and Euler method. Thanks for watching.